Good morning. So in the last class, I was taking up the module 3. Okay, it was the support reactions and analysis of simple truss. So there are two topics. So one is the support reaction and one more is the analysis of simple truss. But I have taken the support reactions. So already in the last class we have discussed, so what are all the types of supports, what are all the types of beams and what are all the types of loads. Yes or no? So now today let me take up the problems on support reactions. Okay, so let me take up the problem. So heading numerical problems. Numerical problems. So let me take up the first problem. Determine the reactions at the support. Determine the reactions at the supports for the beam shown in figure. For the beam shown in figure. Okay, so as usual I have already told you people that for every reaction there is an equal and opposite reaction. Okay, so whatever the load that we are applying on the beam, so that load needs to be taken care by the supports. So whenever the beam is applying the load, what is the reaction that is getting developed near the support, that we need to calculate. So the diagram that they have given is, so a beam, okay, so one side they have given it as hinged support. Okay, I think in the last class I have shown you people. Okay, so this is the hinged support. Okay, and one more is it's the roller support, and one more is the roller support. So this diagram also I have shown you people in the last class. Now the loading condition that they have given is 10 kilonewton, which is acting at this particular junction. They have given this as A, this as B. Okay, so next point as C. So next they have given 1 meter. So they have considered a point here. This is 1 meter, this is 1 meter, and this is 1 meter. They have given a pure moment there. They have given a pure moment, that is 5 kilonewton meter. So this is the diagram that they have given. Okay, this is the beam. We are applying the load onto the beam. So that load needs to be taken care by the supports. Yes or no? So we need to calculate the support reactions. Now what we will do is, first we will write the free body diagram of this. First we will write the free body diagram of the given beam. Okay, so now what I will be doing is, let me extend a line like this. Okay, so first let me write the free body diagram. This is A part. Let me write this one also. This is B and this is C. At A, so which is the type of support that you people are having? So it's a hinged support. For hinged support, I have already told you people how many reaction you will come across. So there will be two reaction, one in the vertical direction, okay, one more in the horizontal direction. So reaction at A in vertical direction, horizontal reaction I will be representing it with H. So horizontal reaction at H. Okay, so I will be calling that as HA. Any problem? Instead of RA, you can also use as VA, that is vertical reaction at A, horizontal reaction at A, no problem. Anything you can use. Next, there is a pure moment. So that pure moment is clockwise, so it's 5 kilonewton meter. Next, which kind of a support is this? It's a roller support. For a roller support, how many reaction you can expect? So one reaction. So for that reason, I will be writing RB here. Okay, so now we are having one more load at the end and that value is 10 kilonewton. So this is the free body diagram that I want you people to remember. So based on this diagram, we'll go further. Okay. So now, so I think you people know the equations of equilibrium while doing the equilibrium chapter, and that too coplanar concurrent force system, coplanar non-concurrent force system. Okay, I want you people to tell me how many equations of equilibrium are there for coplanar concurrent force system. For coplanar concurrent, there are only two equations of equilibrium. One is sigma v is equal to 0, one more is sigma h is equal to 0. For coplanar non-concurrent, so there are three. So one is sigma v is equal to 0, one more is sigma h is equal to 0, and one more is sigma m is also equal to 0. I want you people to concentrate here. Don't you think that, okay, so all the loads are passing through different points. So it's a coplanar non-concurrent force system. For coplanar non-concurrent force system, how many equations of equilibrium will be there? Please remember one more thing in the entire support reaction chapter. So it is a coplanar non-concurrent force system. So you need to go with three equations of equilibrium. One is sigma v is equal to 0, one more is sigma h is equal to 0, and one more is sigma m is equal to 0. Okay. So now keeping that in our mind, so first one, let me go with applying equations of equilibrium. Applying equations of equilibrium, okay. First one, sigma h is equal to 0. What is the sign convention? Right word positive, left word negative. So right word positive. Okay. So now let me go with the free body diagram. Okay. Let me go with the free body diagram. So in free body diagram, how many horizontal force you people are able to see? So you people will be able to see only one horizontal force, and that too HA is acting in rightward direction. So HA is equal to 0 because there is only one force. So I got the horizontal force. Okay. So next, second one, let me go with sigma v is equal to 0, upward direction positive. Okay. So now how many vertical forces are there? RA is the one which is acting in the upward direction, so positive. RB is one more, that is also acting in the upward direction. Okay. Next, is there any vertical force? Yes, there is one more. Don't consider this moment. So it's a pure moment. We are only concentrating on the forces. Okay. So there is one more force which is acting in downward direction. Minus 10 is equal to 0. Or else can I say RA plus RB is equal to 10. Let me call this as 1 for time being. Let me go with the third one. That is sigma m is equal to 0. But about which point shall we take? That is very important. Observe here. So I will be taking up the moment, that is summation of moment about a particular point I need to take. I will give you a clue where you are having maximum unknowns. One thing is sure, either you need to take the moment about A portion or B portion. Wherever you are having supports, take the moment about that particular portion, because you need to calculate the support reaction at that point. So either you consider at A or consider at B. But my suggestion is, where you are having more number of unknowns, take the moment about that particular point. Why, sir? The reason is, whenever you take the moment about that particular point, don't you think that the force which is passing through the same point where I want the moment, that will be 0. So these two forces will be 0. Then the only unknown force will be this. So you will easily get the value. So where you are having maximum number of unknowns, take the moment about that particular point. Okay. So now as per this diagram, I will be taking the moment about A. Sigma MA is equal to 0. Clockwise direction positive. So let me go one by one. So let me hold a finger over here. So now it is the moment. So there is a pure moment. So don't you think that this pure moment is clockwise? So as it is clockwise, plus 5. Next, let me go here. Now observe here where I want the moment, at point A. In which direction the RB is acting? In the vertical direction. Let me extend a line of action where I want the moment. Okay. Don't you think that this force needs to go and touch this particular line in anti-clockwise direction? Sir, why it is anti-clockwise? Why not clockwise? Observe here. Clockwise means it is the longest distance. It needs to go and touch it like this, which is the shortest distance, this one and this one. So therefore, this RB, force into perpendicular distance. Please remember one thing. What is the formula to calculate the moment? Force into perpendicular distance. As it is a pure moment, I have not multiplied with any distance. But now, so I want the force value. So force is anti-clockwise minus RB into, what is the total distance? Let me mark the distance also. This is 1 meter, this is 1 meter, this is 1 meter. So I want the moment about this point. Force is anti-clockwise. RB into what is the perpendicular distance? 2 meter. Next. This is over. Next, this one. Don't you think that? This force is in vertical direction. I want moment about this point. In which direction the force is acting? Extend the line of action. So I want you people to tell me, don't you think that this force needs to go and touch this particular line in this clockwise direction? Anti-clockwise, what will happen? If I go in the anti-clockwise, it is the longest distance. I want you people to go with the shortest distance. So this is the best one. So 10 into 3. So plus 10 into 3. So using the calculator, if you solve for the value of RB, the value that we are getting here is, so the value of RB is 17.5 kilonewton. Okay, so we have calculated the value of RB. So what is the question? Determine the support reactions. So how many support reactions are there? Support means go near the supports. So 1, 2 and here 1. So totally 3 support reactions we need to calculate. Already we have calculated 2. So one is HA we have calculated, one is RB we have calculated. Don't you think that? So if I substitute RB value over here, so from 1, so what happens? So RA plus, what is the value of RB? It's 17.5 is equal to 10. So what will be the value of RA? So 17.5, it will go towards that side. So RA value will be minus 7.5 kilonewton. Please remember, what is this negative sign indicating? That negative sign is indicating that RA here, okay, it is not acting in upward direction, instead it is acting in downward direction, because in the starting we were not knowing. So that's why we have assumed in the vertical direction and the upward direction, but final answer revealing that, so RA is not acting in upward direction, instead it is acting in downward direction. That's it. So this is how you need to calculate. So this completes the first problem. Okay, so what we have done, we have calculated the support reactions. That's it. Okay, so I think you people don't have any doubts in this. Keeping that in my mind, let me proceed with the next problem. So let me take up the same thing. Determine the reactions at the support for the beam shown in figure. Determine the reactions at the support for the beam shown in figure. I will only rubbing the diagram part. And this also. Now observe here. The diagram that they have given is, so they have given 2 supports. So one is, let me not write this much big. So one is the hinged support. The next one is the roller support. So next, they have given an UDL. So the value of UDL is 20 kilonewton per meter. Next, they have given uniformly varying load. All the different types of loads we have already discussed in the last session. So how to convert the UDL to point load? So it's W into L. How to convert the uniformly varying load to point load? It's WL by 2. Okay, so we have already discussed all those things in the last class. So they have given the UVL in this particular form. And the value that they have given is 50 kilonewton per meter. 50 kilonewton per meter. So let me write down the span. They have given this as A, this particular point as B, this is C, and this as D. Okay. So the spans for all those things that they have given is 3 meter for this, this as 3 meter they have given, this as 1 meter they have given, and again this particular point as 3 meter again. Okay. So first let me check how many supports are there. So there are 2 supports, one is over here, one more is over here. Okay. So don't you think that it's an hinged support? So hinge support means 2 reactions. So this is a roller support. Roller support means 1 reaction. So totally 3 reactions I need to calculate. So first let me write down the free body diagram. So let me write down the free body diagram. Free body diagram means what are all the load and what are all the reaction that are coming on the beam. Each and everything will write it. So as it is a hinge support, so one will be in the vertical direction. So I will be calling it as RA, as this is point A. So as it is a hinge, there will be one more, that is HA. Next, it's a UDL. Be careful. It's a UDL. I have already told you people how to convert UDL to point load. Sir, why we need to control UDL? Why we need to convert UDL to point load? The reason is the sign convention that we have assumed is for a point load. Upward positive, downward negative, rightward positive, leftward negative. Yes or no? So that's why we are converting the UDL to point load. What is the formula to convert UDL to point load? It's W into L. So what is the value of W? So W is 20 kilonewton per meter into L means span up to which the UDL has been given. So the span is 3 meter. So meter get cancelled. Finally we are left out with 60 kilonewton. Now the thing is that 60 kilonewton, where it acts exactly at the center. So in the last class only I have discussed all these things. Okay, it acts exactly at the center. So as it is 3 meter, so this point will be 1.5 meter, this point will be 1.5 meter. Okay, so what is the load? So we have calculated, it's 60 kilonewton. It's 60 kilonewton. Next, we'll come back here. Don't you think that it's an UVL load? Okay, so how to convert UVL to point load? How to convert UVL to point load? So I think you people know that it's WL by 2. So what is the value of W? So W is 50 kilonewton per meter into, what is the span up to which the UVL has been given? It's 3 meter divided by 2. So meter get cancelled, 53s are, so 150 divided by 2. So it is 75 kilonewton. But the thing is, in UDL, if I convert the UDL to point load, the point load acts exactly at the center, but not in case of UVL. In UVL what happens? In UVL from 90 degree side. From 90 degree side. So it acts at a distance of L by 3. From 90 degree side, it acts at L by 3 distance. What is the span of the UVL? It's 3 meter by 3, it's 1 meter. So from 90 degree side, 90 degree side means this side. From 90 degree side at 1 meter. At 1 meter. If this is 1 meter, total is 3 meter. Obviously this needs to be 2 meter. Okay. So we have already converted this UVL. What is the value that we got? So it's 75 kilonewton. Done. Now we are having a roller support. So for roller support, I think you people know that you will be having only one reaction, and that point is D. Therefore, I will be calling it as RD. Okay. So now we'll go one by one. This completes the free body diagram. Now I will be moving on with the equilibrium equation. So using equations of equilibrium, using equations of equilibrium. So first one is sigma h is equal to 0, that is rightward direction positive. Okay, so how many horizontal forces are there? So as per the diagram, we are having only one, that is HA, which is acting in rightward direction. So HA, as it is acting in rightward direction positive, there is no other forces, so I need to make it to 0. So there were 3 reactions that I was supposed to calculate. I have already calculated first one. Second one, sigma V is equal to 0, upward direction positive. Okay, so upward direction positive. So which are all the vertical forces? So RA, which is acting in upward direction, 60 minus, we'll do one thing. RA is acting in upward direction, plus RD is also acting in upward direction. So as both of them are acting in upward direction, so it's RA plus RD. Okay, next. There is one more vertical force which is acting in downward direction. There is one more acting in downward direction. So 60 and 75. So those I need to consider it as negative. Minus 60 minus 75 is equal to 0. So RA plus RD is equal to minus 60 minus 75. So it's plus 135. Let me call this as 1 for time being. So let me go with the third one. That is nothing but the moment. But the thing is, at which particular point shall I take the moment? That is important. Yes or no? So that's why what I will be doing is, as I already told you people, so you need to take the moment about the supports. In that also particularly, where you are having more number of unknowns. So what I will be doing here is, so at point A, you are having 2 unknowns. At point B, sorry not B, it's D. Let me mark it. This is B, this is C, this is D. You people might be thinking, sir, HA already I know it. It is not an unknown now. But the thing is, just if more number of forces, take moment about that point. If you take moment about D also, no problem, because here HA is known. But still, I suggest you people, where you are having more number of forces, take the moment about that point. Because if I take the moment about this point, these 2 forces will become 0, because force into perpendicular distance. These forces are acting at a point where I want the moment. So therefore, these 2 will become 0. So that's why what I will be doing, let me take the moment about A point only, is equal to 0, clockwise direction positive. Now observe, let me go one by one. So this force, it needs to go and touch this line. As I told you people, where I want the moment, about A point. In which direction the force is acting? In vertical direction. Let me extend a line of action in the direction of the force. Don't you think that this force needs to go and touch it in clockwise? If it goes in anti-clockwise, it is the longest distance, but I want the shortest distance. Force into perpendicular distance. So force is 60 into 1.5. So it is clockwise. So 60 into 1.5. Next, let me go one by one. Next, this is one more force. Observe here, this is 1 meter. This force is vertical in direction. I want moment about A point. In which direction the force is acting? Extend the line of action along the direction of the force where I want the moment. Next, this force has to go and touch this in clockwise direction. Yes or no? So it needs to go and touch it in clockwise direction. So plus 75 into, what is the total distance from this force till the support? So it's 1 meter, 1 meter, 1.5, 1.5. 3 plus 2, 5 meter. Next, there is one more reaction which is acting in upward direction. So the force is vertical, extend the line of action in the vertical direction itself. Okay, extend the line of action in the vertical direction itself. Don't you think that this force needs to go and touch it in anti-clockwise direction? So RD is negative minus R into D into, what is the perpendicular distance? It is nothing but the total span of the beam. So don't you think that it's 7 meter? So it's 7 meter is equal to 0. So now if I calculate the value of RD, so what is the value of RD that we are getting? So the value of RD that we are getting is 87.85. 87.85 kilonewton. Okay, substituting this in equation 1. So from 1. Okay, so RA, that only I need to calculate. plus RD, just now I have calculated it, 87.85 is equal to 135. So finally the value of RA, if I transfer it towards that side, 135 minus 87.85, so the value that I am getting here, so it is 97.15, 97.15. Okay, so it's 97.15. So I have calculated all the three reactions. So the problems are very simple. The only concept that I am using is just convert the other types of loading to point load, then apply equations of equilibrium. So that's it, nothing else. Okay, so now let me move on with the third problem. Okay, so now third problem, same thing, determine the reactions at the support for the beam shown in figure. So the beam that they have given, it is slightly different. Shall I rub this? Done. I will be rubbing this. Okay, so now the diagram that they have given is, it's in this pattern. Okay, so at one junction they have given it as the hinge support. At the one more junction, now there is a twist in the problem. Observe. The twist is, the support is not in a vertical manner, instead it has been inclined. So please be careful. Whatever the dotted line that I am showing, it is the line that I am drawing, not given in the question. Next, they have given one more thing. We'll do one thing. This dotted line will draw later. So they have given one more. This line they have given, this angle theta they have mentioned, and they have told that this is 2 and this is 1. Completely different kind of problem. So now this is A point. Okay, so at B, you people are having an inclined force. At B, you people are having an inclined force, kilonewton. At what angle it is inclined? So it is inclined at an angle of, just a minute, 60 degree. Okay, it has been inclined at an angle of 60 degree. Next, this is B point. And the span. Okay, so the span that they have given is 1 meter. Next, there is one more. There is one more UDL that they have given. This point they have considered it as C point, and for that particular point also they have given it as 1 meter, and this particular UDL portion they have given it as 3 meter. So now what is the value of UDL? So it's 50 kilonewton per meter. It's 50 kilonewton per meter, and this point they have given it as D. So A, B, C, D. So as usual, how many supports are there? 2 supports. Okay, so now don't you think that it's a hinge support? For hinge support, 2 reactions, one in the vertical direction and one more is in the horizontal direction. So which kind of a support is this? Roller support. For roller support, how many reactions you can expect? So obviously I can expect one reaction in the vertical direction, but here it's in an inclined manner. Even though it is in an inclined manner, I need to show the reaction in this pattern. So please remember, I will be writing this as RD. It's the alteration that I am doing. In the question they have not given this. I am doing the alteration part. Okay. But the thing is, what is the sign convention that we are using? Exactly upward, positive, downward, negative, leftward, leftward, negative, rightward, positive. Exactly horizontal and exactly vertical. Forces sign convention, I know. But here there is an inclined force. Here also there is an inclined force. So what to do? So observe here what I will be doing here. So we'll do like this. Can I extend this line? Observe here, this is very important, be careful. Observe here, this is very important. Can I extend the line like this? Observe here, I am doing the alteration part now. So I am extending the line like this and I am joining this line. Can I do it? Of course you can. And one more thing, I think you people know whenever a reaction develops at a surface, so it always develops at an angle of 90 degree in the equilibrium chapter. Okay, I think you people know that whenever the reaction is developed, okay, so it develops at an angle of 90 degree with the surface. Next thing, don't you think that it's the same line? And don't you think that this line and this line are exactly horizontal? So if this is theta, don't you think that this is also theta because of corresponding angles? So for that reason, what I will be doing here is, first let me calculate the value of theta. So shall I apply tan theta? Tan theta is equal to opposite by adjacent. So what is the value of theta that we are getting? So the value of theta that we are getting here is, just a minute, so it's 26.56. It's 26.56. Now the important thing is, observe, I want everyone to concentrate here. If this is theta, this is 90, can anyone tell me what is this angle? Sum of the interior angle of a triangle should be 180 degree. So theta value I know, plus 90 degree, plus, for time being let me consider this as alpha, is equal to 180 degree. So then what is the value of alpha? So the value of alpha that we are left out with is 63.44. 63.44 degree. So I got this value, 63.44 degree. Sir, why you are doing all these things? The reason is, this reaction is in an inclined manner. So I don't have the formula to calculate the inclined forces. So first I need to convert this inclined forces into exactly horizontal and exactly vertical. Yes or no? So that's why I am doing this. Observe here. So this is in an inclined manner. If I want to resolve it with respect to horizontal, I want to know this particular angle. So that's why what I will be doing, observe here, I will be extending this line. If this is 63.44, so don't you think that using the alternate angle concept, what will be this particular angle? So it's 63.44 degree. So now the inclined force is there. I know the angle. I want you people to tell me the force with which line it is inclined, or the force with which line it is making an angle. That will be cos, and the force is acting towards the point. Therefore its resolution should also act towards the point. So what I will be doing here is, so the resolution should also act towards the point. So this will become what? So it will become RD cos 60. The inclined force with which line it is making an angle, that will be cos. The other one will be sine. Other one means the force is acting in an inclined manner. So this is the vertical force. So the vertical force is RD sine 60. So any doubts in this diagram? And obviously one more thing, this is also an inclined force. I don't have any sign conventions. So what I will be doing, first I will do one thing. First let me write down the free body diagram. So this is A point, this is B point, this is C, this is D. So at A point, you are having a hinge support. Hinge support means two reactions, one in the vertical direction, one in the horizontal direction. Yes or no? Next, so here you are having an inclined force. I want you people to tell me now, this inclined force, with which line it is making an angle? Okay, so that will be cos. If I resolve this towards the horizontal direction and the force is acting towards the point, therefore its resolution should also act towards the point. So this will become 100 cos 60. So this inclined force, with which line it is making an angle, that will be cos. Then the vertical one will be sine. And that force is also acting towards the point. So it's 100 sine 60. Okay. Now let me convert this UDL to point load. How to convert UDL to point load? UDL to point load. It's W into L, right? So it's W into L. What is the value of W? 50 kilonewton per meter into. So what is L? So L is nothing but 3 meter. So meter get cancelled. So it's 150 kilonewton. And don't you think that 150 kilonewton act exactly at the center? So this 150 kilonewton acts exactly at the center. So as it is 3, so this will be 1.5 meter and this will be 1.5 meter. Now already I have resolved this inclined force RD, it was in this direction. So now I have converted it. So one is in the vertical direction and one more is in the horizontal direction. Okay, horizontal direction, it is RD cos 60. What is the value of cos 60? So the value of cos 60, I think we have written it as it is. So let me write the same thing. So it is RD cos 60 and the vertical one is not RD. Yeah, let it be RD cos 60. This is also RD sin 60. So this is the free body diagram that you people need to write. So the only change is the support is not in a vertical manner. Instead, it has been given in an inclined manner. Whenever they have given it in an inclined manner, this is the procedure that I want you people to follow. Okay. So now I have done each and everything and I have written the free body diagram. Now the same thing, applying equations of equilibrium. But be careful now. So using equations of equilibrium, sigma h is equal to 0. How many horizontal forces are there? Please be careful now. So HA is the one which is acting in rightward direction. Okay. Next, there is one more force which is acting in rightward direction. Okay, it is 100 cos 60. So plus, because it is acting in rightward direction. So 100 cos 60. Okay. Next, anything else? Yes, we are having one more. So minus RD cos 60 is equal to 0. Okay. So finally what happens is, the final value that we will be left out is just a minute, cos 60, it's 0.5. Okay, so let me leave it as it is. So HA minus RD cos 60. Okay, if I transfer this towards that side, it will become minus 100 cos 60. This will deal later. Okay, so now let me go with sigma V is equal to 0. How many vertical forces are there? We'll apply that. Okay, so sigma V is equal to 0. Vertical direction. There is RA which is acting in upward direction. Okay. Next, there is one more acting in downward direction, minus 100 sine 60. Next, there is one more which is acting in downward direction, minus 150. Next, there is one more which is acting in upward direction. So it's RD cos 60 is equal to 0. So what I will be doing is this also I will be calling it as equation 2. Okay. So now I need to take the moment about certain point. Okay. So if I want to take the moment about certain point, so either I need to take the moment about A or I need to take the moment about D. Okay. So now where you are having maximum unknowns? At A. Don't you think that HA is also unknown, RA is also unknown? But don't consider D point. The reason is RD and RD, even though there are two forces, unknowns are only one. So let me take the moment about A point. So whenever I take the moment about A point, what will happen is this entire thing will become 0. Next, this horizontal force, what happens? This horizontal force and this horizontal force. What is the formula to calculate the moment? Force into perpendicular distance. Yes or no? So now what happens is this horizontal force, don't you think that the force and the point where I want the moment, they are in the same line of action? Also this. So I can neglect this and this. So I am left out with this now. So it's 100 sine 60 and it go and touch it in clockwise direction. 100 sine 60 into, this is 1 meter, this is 1 meter, this is 1.5, 1.5. So it is clockwise 100 sine 60 into 1. Clockwise 100 sine 60 into 1 meter. Next, there is one more, 150 kilonewton. It goes and touches in clockwise direction. So what is the total distance? 4.5, sorry, 3.5. So clockwise is 150 plus 150 into 3.5. Next, there is one more which is acting in upward direction. It is anti-clockwise. Minus RD sine 60 into minus RD sine 60. Okay, into. So what is the total span? So it's 5 meter. So these are all the forces. Let me equate it to 0. Just by seeing this, you can say that there is only one unknown, that is RD. So using the calculator, what is the value of RD that we are getting? It's 133.19 kilonewton. So RD value is 133.19 kilonewton. 19 kilonewton. Okay. So now what I will be doing is, let me substitute this in equation 2, because here the unknown is RA, here the unknown is RD. I know the value of RD now. Substitute it back. So from 2. So from 2. So what happens is, so RA I need to calculate minus 100 sine 60 minus 150. I know the value of RD, just now I have calculated. It's 133.19 into cos 60 is equal to 0. So after solving this, okay, so what is the value of RA that we are getting? So it's 102.17 kilonewton. 102.17 kilonewton. Okay, I have calculated RA also. Now substituting the value of RD in equation 1. Okay, so from equation 1. So now HA I need to calculate. Okay, minus RD value. Already we know it. It's 133.19 into cos 60 is equal to minus 100 cos 60. So after solving this, the value of HA that we are getting here is, the value of HA is minus 12.1 kilonewton. Minus 12.1 kilonewton. So what is this indicating? Negative sign. It indicates that in the starting I was not knowing, so that's why the horizontal force I have taken it towards the beam, but the answer is indicating it is not to be taken towards the beam, it needs to be away from the beam. Okay, so it means that HA is equal to 12.1 kilonewton in leftward direction. That's it. So what was the heading? Find the support reactions. So there were 2 supports and 3 unknowns. One is HA, one is RA, and one more is RD. Yes or no? So now what I will be doing, but the problem will not stop at this particular point. There is one more there is one more step. Observe here, in the other 2 problems that I have solved, just remember that, don't you think that in both the problem HA was 0? So HA was 0. But here we are having a value for HA, we are also having a value for RA. Whenever at a point you are having two values, You should not stop at this stage. You need to continue further. So that is nothing but the resultant force at A. Because whenever there are two forces acting, I need to calculate the resultant force at A. Observe here. So finally what I will be doing is resultant at A. Resultant at A. So that is, observe, RA final value will be given by square root of, so HA square plus RA square. We'll do one thing, I will be calling it as R dash because already RA I have given it for the vertical force. So RA square. What is HA value? Don't consider the negative sign. So it's 12.1 square plus, what is the value of RA? It's 102.17 square. So after solving it, so RA dash, that is the resultant force at A, is given by 102.88 kilonewton. 102.88 kilonewton. So please remember this. Okay. Don't stop at this stage also, because at what angle? So it has been inclined. That also we need to calculate. For that what I will be doing, alpha is equal to tan inverse of sigma h athva, or I can say HA by RA. This is very important and it is compulsory also. So whenever at a point you are having two forces, you need to calculate the resultant as well as the direction at which it is inclined. So HA is 12.1. Okay, next. The other one is, just a minute, it's tan inverse of sigma V by sigma H, sorry. So it means that RA by HA. So what is the value of RA? So RA is 102.17 whole divided by, what is the value of HA? So HA value is 12.1. So what is the value that we are left out with? So the final value that we are left out with is 83.24 degree. 83.24 degree. So please remember this. Okay. So whenever at a support you are having two forces and for both the forces you are having value, then you need to calculate the resultant. Also you need to calculate the direction at which it is inclined. So I think you people have understood these three problems. So today I will be winding up my session. I will be continuing the further problems in the next class. So thank you.